Traditional business models in the energy sector are being reshaped by emerging innovations. More and more consumers now use small-scale solar or wind installations to produce electricity, and they even sell their surplus power. At the same time, renewables force traditional power plants to uphold their social license to operate by shrinking their environmental footprint. However, renewable energy sources are subject to output fluctuations as weather conditions change. For this reason, load-balancing power plants remain vital to meeting energy demand, especially during consumption peaks. Energy efficiency is a key part of satisfying this demand. As power plants age, efficiency and thus output decreases. To maintain high performance throughout a power plant's life cycle, well-planned maintenance and skilled operators are needed. A plant's energy efficiency can even be considerably increased by implementing customized life cycle upgrades to the entire plant or equipment. Combined, these actions provide commercial, operative, and environmental benefits.
We are living in times of the biggest change in the world of energy since decades, as clean energy has reached economic feasibility. The decreasing cost of renewable power generation is driving a growth that exceeds all previous forecasts. In 2016, 1/4 of generation capacity additions globally was photovoltaic solar. This brings more intermittence in power systems and impacts traditional baseload generation. Therefore, flexible gas-fired power generation is playing a growing role to keep the power systems efficient and in balance, replacing other traditional fuels and less flexible technologies. Also, energy storage is emerging as the ultimate source of flexibility. The future of energy will be based on renewables as new baseload, together with flexible generation and energy storage to keep power systems balanced and manageable. Already today, we see demand for hybridized solutions, integrating renewables and flexibility as smart energy systems.
Our customers are looking into ways of maintaining and improving the energy efficiency of their power plants into the future. There are many means of achieving that, from the replacement of a single component to complete modernization or operation and maintenance solutions. There are also many aspects that affect the efficiency of a power plant, and these need to be carefully examined before choosing the optimal solution. Some key factors are fuel consumption, fuel price, price of electricity in the operating area, and the maximum output of the power plant. As digitalization advances, power plant operators will be able to forecast power consumption and maintenance needs more accurately and adjust their operations accordingly. Today, our Wärtsilä expertise centers across the world analyze real-time data around the clock. Their remote operational support ensures that our customers are well cared for, anywhere, anytime.
The Delimara power station site is the cornerstone of Malta's energy portfolio. It currently serves as the only local power station site on the island, together with a 220 volts AC interconnector cable coupled with Sicily grid. The Wärtsilä engines power plant is one of the installations situated in Delimara power station. Since hundreds of thousands of Maltese citizens and businesses depend on Delimara for steady power around the clock, baseload and also peak plants inside Delimara station need to be efficient and reliable. An analysis on the 3 power plant showed that 8 Wartsila HFO-fueled engines could be converted to run on natural gas. This would reduce both emission levels and electricity production costs. Also, operating and maintenance costs would be lowered. Even more, and from a social aspect, running on natural gas would highly reduce air emissions, particulates and sludge production. Fly ash disposal requirement would in fact go down to zero and sludge disposal significantly reduced. Wartsila handled the engineering, procurement and construction necessary for the gas conversion. They installed a new engine control system and constructed a 500-meter natural gas pipeline complete with a pipe bridge, valves, instrumentation and relevant control functionality. New auxiliary modules were also introduced. These range from a compact gas ramp, per-jar fan modules and gas leak detection systems to rupture discs on exhaust gas ducts and the nitrogen inertization system. Control and functionality modifications were also engineered to accommodate new plant operational exigencies on all main and auxiliary systems. The commitment of Wartsila's personnel and their service-minded attitude allowed us to stay on schedule. This project brings substantial benefits. Our plant will remain compliant with foreseeable EU emission regulations. The new engines run at a lower heat rate with increased efficiency and higher power output capacity. The 8 engines run on natural gas, but 4 of them can use also LFO as a backup fuel. In addition to this positive environmental impact on operation flexibility with 2 types of fuel, we also have significantly reduced our operational workload due to less complicated exhaust abatement requirements and no need of HFO fuel refinement processes. The cost per megawatt hour is even cheaper with natural gas than the former fuel. We appreciate Wartsila's contribution to this project and would certainly recommend other power plant owners to look into the possibility of a gas conversion.
The Plains End plant here in Denver, Colorado is one of the world's largest natural gas-fired peaking power plants with reciprocating engines. The 34 engine generator sets provide a total combined output of approximately 228 megawatts. We use the site to rapidly respond to market demand. For example, whenever wind turbines are not producing the needed power for the grid, Plains End could be started in approximately 8 minutes to fill that gap. At Plains End, one of the projects we developed in the last couple of years was to better stabilize raw engine emission levels without sacrificing heat rate. The solution we found to be the most beneficial for us was Wartsila's pre-chamber upgrade for 14 of our 34 engines. A pre-chamber serves as the ignition source for the main fuel charge and is one of the critical components of natural gas-fired lean burn engines. By upgrading, we aim to achieve more stability in combustion. This in turn would lead to increased emission stability and overall better efficiency. Wartsila's solution also serves as an effective tool for optimizing combustion dynamics. This improves engine performance and offers a better balance between heat rate and NOx emissions. This upgrade means a lot to us. We used to walk a thin line between heat rates and emission controls. Using Wartsila's upgraded pre-chambers, we provided extra room for improved efficiency and stable raw engine emissions. Further, our data shows that the Plains End plant now burns less fuel, shrinking our ecological footprint. We sincerely appreciate that Wartsila employees lent their expertise not only during the installation, but during the fine-tuning phase after the installation was complete to make this a very successful project.
We wanted to improve the performance and optimize operational cost of our Nepui power plant to increase our competitive edge. We determined that enhancing the site energy efficiency and lowering fuel consumption were key areas with room for improvement. Until 2008, Nepui was a base load plant, but it has since been used as a peak load plant. In 2014, fuel costs for this site were approximately 73% of its total operational cost, with an average consumption of about 55,000 tons of fuel annually. As Nepui is a government-owned site, optimizing fuel consumption was one of our main targets. We knew that it was achievable with modern solutions and the right partner. We decided to proceed with a performance optimization upgrade. It consisted of engine tuning, enabled by a unique camshaft modification and turbocharger upgrade for 2 of the plant engines. And timing was critical. all required work needed to be executed quickly and within a very limited period of time. Installation and commissioning were conducted during a scheduled engine overhaul, which minimized downtime. We were pleasantly surprised by the performance optimization, even beyond expectations. Tests show specific fuel oil consumption saving of over 5 grand per kilowatt hours. Simply put, this means in 2016, we managed to save about $400,000 thanks to the performance optimization. The primary goal, cutting fuel consumption, were clearly achieved, and we expect to continue to enjoy the benefits of this upgrade going forward.
Power plant operators today have a wide range of available options to increase energy efficiency. These allow power plants to not only function more efficiently, but also extend their equipment life cycles. Through Guaranteed Asset Performance, a Wartsila Lifecycle solution for power plants, performance targets are set together with the customer, and Wartsila ensures they are reached. Our advanced performance analytics, remote operational support, and maintenance management services ensure plants remain in top condition, which prevents disruptions. Through Wartsila's Energy Efficiency Management Service, fuel efficiency is monitored by our expertise centers, which provide guidance and advice for power plant operators and managers in order to optimize fuel efficiency. Guaranteed levels of energy efficiency can be achieved through engine performance upgrades. For example, state-of-the-art turbochargers can be installed or existing engines can be converted to use natural gas. A power plant life cycle upgrade can restore a power plant's operating efficiency to its original state or beyond through actions that correct excessive derating. A site audit by Wartsila energy efficiency experts can determine the processes and equipment with the biggest improvement potential.